Hi, my name is David Lightbown, and welcome to this Autodesk University Media and Entertainment Masterclass. The title of this masterclass is Transforming Through Textures. What we're going to do in this masterclass is we're going to read image data, so we're going to take in textures, and we're going to read through those images pixel by pixel. And with that information, we're going to do a whole variety of things. We're going to be using Softimage and Maya. We're going to take data from Softimage, and using the interoperability tools, we're going to bring that data into Maya from Softimage. And we're going to, using the pixel data from those images, we're going to rotate objects, we're going to change their texture, hence the title Transforming Through Textures. So without further ado, let's get started. Who am I? I've spent many years doing contracts for Autodesk. Here's one of the first examples that I did. It was a DVD entitled Modeling with Math in Maya. The goal of the DVD essentially was to teach very basic mathematical formulas, such as Pythagoras or the area of a triangle, how to transform those formulas into MelScript, and then how to create tools in MelScript to be able to aid make production more efficient. So moving on, here is an example of the post-secondary, the official post-secondary Maya training manual that I produced with Autodesk. It was a manual that covers Maya from A to Z, and has a student manual as well as a teacher manual with a variety of exercises inside. Moving on, more recently I've done a whole series of podcasts with Autodesk, and I've got an example here, in fact, that I can show you. So here's an example of modeling with dynamics. Typically, when you think about modeling with dynamics, you think about doing things like cloth. But here's an example where I have a cannon that fires a variety of particles at a wall, and as soon as those particles impact on the wall, a bullet hole object is created and placed right where the particle impacts into the wall. So fairly technical. It gives you a bit of an idea of the kind of stuff that I do. And very recently, I was very, very honored to be nominated and finally won the Autodesk Maya Master Award in 2010. I'd like to thank everybody out there who voted for me. I really appreciate it. And as I said again, it was a very big honor to receive that award. I also speak at a variety of conferences. I've spoken several times at the Montreal Game Summit, at the Game Developers Conference as well, in San Francisco as well as in Paris, on mostly either working with Autodesk or doing talks relating to the games industry. And a couple of years ago as well, I did a masterclass at SIGGRAPH, which was also the source of the DVD, the Modeling with Math in Maya DVD. So let's dig in and talk a bit about what this masterclass is all about. Essentially what I've done is I've taken a variety of different installation art pieces that inspired me personally, and when I see interesting installation art, especially art that has an interesting technical aspect to it, I always wonder, how could I recreate that in Maya? So here's one example by an artist called Daniel Rosen, called the Peg Mirror. And here are a couple of screenshots of it. And there's a close-up. Now I have a video that I'll show you to give you a better idea of exactly how this works. So here we go. So basically the way that the peg mirror works is there are these pieces of wood, these pegs, that have been cut at an angle. And they've been arranged in such a way that they represent sort of a grid of pixels in this way, sort of a round group of pixels. And there's a camera in the middle. And there's also a light source from the top shining down on these pegs. And when the pegs face the light, they become brighter, and when they face away from the light, they become darker. And the camera in the middle films the image that it sees, and it turns the pegs based upon the brightness of the pixels that it sees. So the artist has created this sort of same concept in a whole variety of different shapes, and I thought it would be very interesting to try to reproduce that. So that's one of the things that we're going to look at in this masterclass. The next example here I wanted to show you is called the Crayon Series by Christian Faure, and I hope I'm pronouncing that right. It's either Faure or Faure. Essentially, what he's done is created these beautiful pieces of art, essentially reproducing photographs, but by dropping individual crayons, different colored crayons, into a variety of boxes. So you can see an example here from far away. It looks like any old image. But as you get closer, you start to see that it's broken up into little individual colored pixels. And as you get very close, of course, you see all of the different colored crayons. So very, very beautiful work. You can see on his website, there's a whole variety of examples here that you can take a look at. So again, when I saw this, sort of in researching different ways to manipulate image data, I thought this would be a really, really beautiful and very interesting piece of art to recreate, and a very interesting technical challenge as well, of course. And finally, just to take things a step further, I also was inspired by something here locally in my hometown of Montreal called La Vitrine Culturelle, which essentially translates to roughly the window on culture. It's created by a company called the Moment Factory, and it's just outside a cultural center here in Montreal called Place des Arts. And you can see here that it's a whole series of LED lights, but the lights actually interact with the people when they walk by. And again, I have an example here. So you can see close up, it's simply a series of lights. But as people walk by, I'm assuming there are cameras inside that detect people walking by, and they interact with the people as they walk by. So you see this guy walks forward, he walks backward. As these people walk by, these shapes pop up and move with them. So the same sort of thing, I thought to myself, this would be really interesting to try to take this idea, to take Christian Farr's idea, and potentially maybe to combine them together. So we're also going to take a look at how we're going to recreate this as well in this masterclass. So here we are in Maya. Here's an example of the final scene, essentially all assembled. And on the left, we have data that was brought in from Softimage using the interoperability tools. And on the right, we have something that was generated directly in Maya. So you can see it's been set up to resemble an art gallery to represent the concept that I was going for, trying to take people's art and reproduce it in 3D software packages. So I'm just going to go ahead and start the animation here, and you can see on the left here we have our Softimage example, on the right our Maya example. I'm just going to go ahead and zoom in to the Softimage example to give you an idea of what that looks like. So you can see we have a variety of sort of colored pixels here, sort of like the LED lights that we saw in La Vitrine Culturelle. And as I zoom in and sort of turn the camera off to the side, you can see that it's made up of all these little individual objects. And in fact, I can go ahead and isolate that just to give you a good idea of how that looks. So again, as we get close, you can see all these colors are changing, and as we zoom out, you can see how it resembles an image. We can see Andy Warhol's Marilyn Monroe there. So that's the Softimage generated image rather. And now let's go ahead and look at the image that was generated in Maya. So this is the peg mirror concept. So I'm just going to go ahead and give you a good look at it here. So if as I move over to the side, as I move over to the side, you can see that it's made up of all those little individual wooden pegs, like we saw in that example. But as I move the camera away, we can see that we have a source of light here coming from the top, as I mentioned before. And it illuminates the pegs in such a way that makes you see Einstein or Washington or Che Guevara. But again, if I zoom in, and in fact I'll just go ahead, just like I did before, take this and isolate that. So you can take a look at that. Gives you a pretty good idea of how it works. As I tilt the camera, you can see it's kind of fun to zoom into it really close and see all these pegs moving, and then to zoom out and get an idea of the sort of image that it's forming. So that is the image that we're going to go ahead and create. I'm just going to go ahead and grab these objects and delete them, because we're going to start from scratch and rebuild both of these and assemble them in Maya. Let's go ahead and get started in our Softimage segment. Now the idea here is that we're going to use Softimage's ice feature, and we're going to create a particle cloud, and we're going to take in some image data, a texture, and we're going to change the color of the particles based upon the image. So we're going to find the particles closest to a certain pixel on the image, and then we're going to change the color of that particle based upon the pixel color that it detects underneath. And we're also going to do a whole variety of other things as well, change the colors of the particles based upon objects that are close by, all again in an effort to recreate what we saw in Christian Farr's art as well as the Vitrine Culturelle. So let's go ahead and get started. So we're going to switch over into Softimage here. You can see that I've got a new scene. So the first thing that we're going to go ahead and do is we're going to go into the Primitives panel here, into Polygon Mesh, and we're going to go ahead and create a grid. Now I'm going to bump up the subdivisions to 32 by 32. And speaking of grids, I'm just going to go ahead and hide the grid here so we can have a better view of our object and switch from wireframe over to shaded. So there we go. The next thing that we're going to do is we're just going to go ahead and apply a texture projection in the planar XZ, just to confirm that we have a texture projection on our object as well, because we're going to want to map our texture right on top of that. And then finally, if I go into the properties here, I'm going to finally apply a texture map. Now for now, we're just going to leave the no icon underscore pick just as a test so that we can see if our little technique is working. So the next thing that I'm going to do is I'm going to go into the Create menu here, and I'm going to select Basic Emission. And what that's going to do is it's going to create an ice particle cloud that's going to be emitted off of this grid. So you see if I scrub the timeline, you can see particles coming out of that grid. I'm just going to go ahead and bump up the timeline to 500 units here. And we are going to click on the this button down here, the Ice Tree Render Tree Animation Editor button. That's going to modify the layout to something that's going to be a little more conducive to working on ice. So if I go ahead and zoom in here, I can see that what was created basically is a get grid, which gets the information from my grid and pipes that into an emit from geometry, which is why we have particles coming out. And then finally, that plugs into simulate root along with a simulate particles node here, which goes into the ice tree. And that is basically all the nodes that allow you to see particles coming out of this grid. So for the purposes of our example, though, I don't want particles to be emitted off of the grid and fly up in the air. I want them to basically be spawned one particle on each point on this grid to simulate our LED, or either a collection of lights or a collection of colored crayons in the case of Christian Farr's work. So I'm going to go ahead and delete these three nodes here, and I'm going to pull in a few new nodes. So the first one that I'm going to pull in is going to be a get data. I'm going to press enter there, and it's going to filter my list. I'm going to pull this in here, and I'm going to go ahead and type point position. Now I can go ahead and type that. I can also go into Explorer here, and I can go ahead into Polygon Mesh and scroll down and choose it from this list. And I'm just going to go ahead and plug out name into in name. And I'm also going to go ahead and type emit from position, and that's going to filter the list again, give me this emit from position node. And I'm going to plug in a value into emit position. This yellow line here essentially represents a whole series of values, or an array of values. In this case, we're going to have a whole array of particles. And finally, I'll click the emit, I'll connect the emit into the port here. And if I scrub my timeline forward, you can see that I have a whole series of particles being emitted from each of the points. Now what I want, in fact, is just one particle coming out of each point. So I'm going to go ahead and double-click on the emit from position node here. I'm going to modify a few of the settings. So first I'm going to select rate type to total number of particles. I'm going to set rate to 1, and I'm going to put speed to 0. Go ahead and close that. And if I pull back on the timeline and scrub forward there, I can see I have one particle on each point of the grid. Now it's a little hard to see, especially when I select the grid. So I'm going to go ahead and double click on emit from position. And down here in the shape, I'm going to choose blob. I'll close that. And we'll scrub back and scrub forward. And there we see we've got a much easier view of our particles here. So I'm also going to hide the texture support and the grid, and we're going to change the background color back to black so that we can get a better idea again here of our setup. So we have a whole bunch of points, a grid of 32 by 32 particles, but they're all yellow. So now, of course, we want to be doing something more interesting with them. In other words, we want to connect some texture data into those. So how do we do that? We have to bring in a few nodes. So we're going to start off with get point position. Now, what does this do, and how is it different from this one? Get point position, or get dot point position here, essentially gets the point position on the grid. Get point position here basically gets the position of a particle. So I'm going to go ahead and move that over a little bit to the left. And the next thing I'm going to bring in is get closest location. I'm going to drag that out. So what this is going to do is it's going to allow us to detect the closest location on our texture map to a certain particle. So I'm going to plug the value here, the yellow into position for get closest location. And I'm going to go ahead and drag the purple here from get grid from value into geometry. So I'm going to move these a little bit over to the left. So we're going to be adding a few more nodes on the right side here. The next thing I'm going to bring in is going to be a get data. There we are. Okay, and the data that I want in this case is a texture map. So I'm going to go ahead and type in texture map, which is the map that we have here. We can do that, or we can go ahead and pick. There are a whole variety of different ways that we can do it. And it stays red here because I don't have anything plugged into it. So I'm just going to go ahead and take the out out of get closest location. And I'm going to plug that into location here into source. So basically, this is the source from which I am going to be reading my pixel colors. And then finally, I'm just going to type in set particle color. This is going to finally let us modify the colors of the particles. So I'm going to plug value into color here, and then plug execute into the final ice tree. So you can see now that when we scrub, we have something that looks like the no icon pick. So there we have our different colors, our blues, our greens, our purples, etc. See, if I open the texture map here, you can see it matches up. So let's go ahead and change that texture map now. I'm just going to double click here again. I'm going to go to new from file. And I've prepared a variety of different images for use with this masterclass. So here we'll go ahead and select that. And I have a little Softimage logo that I'm using here, and you'll see there I'm going to start over and scrub across. But we can barely see what's going on here. I'm just going to change the background to gray. All we see is just a couple of pixels. So the reason why that's happening is because we don't have the resolution to be able to see the image properly. It's only 32 by 32 pixels. So what we're going to do is we're going to grab our grid, and we're going to show it here. And I'm just going to go ahead and scale that up. Something like that. I'm going to move it over a little bit. We'll hide it again, and I'm going to scrub backwards and forwards. And there we can see, because we've scaled up our source, because it's reading a more focused part of the image, we have a better resolution here. I think we can probably scale it up just a little bit more. And we'll hide it again and take a look. There we go. So now what I'm going to do is, if I show my grid again, I'm just going to advance a little bit here. I'm going to actually move this all the way to the right. I'm going to set a keyframe there. I'm going to move this all the way to the other side, to frame 500. And I'm going to set a keyframe there as well. Go ahead and hide that and zoom back out. And when I press play, we can see we have something that looks sort of like a ticker, that you would see showing stock market prices. But in this case, of course, it's a Softimage logo. Now, we do have one small issue, though. You can see at the beginning we have these transparent these particles that for some reason appear transparent. The way to fix that essentially is I'm going to go into my texture map here. I'm going to click on Edit in the UV property, and I'm going to check both U and V here in the wrapping. And now when I start over, those pixels are filled in. We have something interesting that looks like kind of a little ticker going across the screen. And again, if I'll make this full screen and kind of zoom in, you can see we have our particles changing color as our image scrolls by. So before we continue, we're going to go ahead and throw this into Maya, again using the interoperability tools, to be able to see how this is going to look in Maya. Before we begin, it's very important to select exactly what you want to send to Maya. If you select nothing, it's going to send the whole scene. In our case, we just want to select, just want to send the point cloud. So I'm going to go ahead and select the point cloud first. So again, very simple. We go into the File menu, we go into Send to Maya, and we're going to go to Send as New Maya Scene. So what it's going to do here is it's going to cache all those particles, and it's going to set that up, and it's actually going to go ahead and open Maya for me, which is really nice. And it's going to do everything. It's going to do all the work. It's going to load in all the particles. There we go. It's created a scene for me. And if I zoom out a little bit here and I scrub the timeline across, I'm just going to actually go into set my timeline to 500 as well. If I go into shaded mode there, if I pull my pull the timeline across there, you can see the word Softimage. It's a little hard to see, so I'm going to go ahead and select my particles. I'm going to scroll down into the render section, or a shading rather, and go ahead and select blobby, just like I did on the Softimage side. So see, as I scrub across, I've got the exact same thing as I did in my Softimage scene, and there it is. So it looks pretty much the same. So there we go. So we've got a connection going on between both of our softwares. And what do I mean by that? What I mean is, in the bottom right hand corner here, we have this update button. And what that lets us do is anytime we make a change in Softimage, it's going to be updated in Maya. So it's a really easy workflow, and we can go back and forth between the two. So the first thing that I'm going to do is I'm going to go ahead and change my texture. So I'm going to open up my grid and select my texture map here. And I'm going to go to New from File, and I'm going to select that image of Marilyn Monroe that we had. So as I scrub along there, you can see we've got Marilyn's eyes in close-up, zooming across. So that's pretty neat. That looks good. So let's go ahead and try that out in Maya. So I'm going to select my point cloud, click on Update, and again it's going to cache all those particles to File, all the colors, the animation, everything, and it's going to just go ahead and send it over to Maya. And all I have to do is just Alt-Tab over, and there we go. We've got our, in fact, if I change the background color, it'll be a little bit easier to see. And there we go. We have our animation of Marilyn's eyes going across the screen. So that gives you a basic idea of how that works. Now let's go ahead and make things a little more interesting here. I want to also simulate the effect that we saw before, where we had people at the Vitrine Culturelle walking in front of that series of LEDs, and it appeared as though the LEDs were following them as they were walking back and forth. So how can we do something like that? So we're going to add a few more things into our ice tree here. So the first thing that we're going to do is we're going to create an object that's going to modify the color of the particles. So we're going to go ahead into primitives and polygon mesh here, and I'm going to bring in a cylinder in this case. Now I want to have a few more subdivisions around the outside to be able to give it a bit of an interesting shape. So there I've got something there, and I'm just going to go ahead into polygon selection mode, and I'm going to select a few polygons on the outside here, going all the way around. I'm going to Control D to duplicate, go to the Move tool, make sure that I'm in local, and I'm just going to push the arms out a little bit here. So there we go. So we've got our object, and what we're going to do is we're going to find the particles that are inside this object, and we're going to modify the color of those particles. So the first thing that we're going to do is we're going to go ahead and grab the cylinder and bring it into our ice tree here. So very simple. Just go ahead and click and drag the cylinder from the Explorer directly into the ice tree. And the next thing that I'm going to do is I'm going to pull out a node called Point in Volume. So let's pull that into our scene here. And you can see that there are two important inputs here for us. One is geometry, and what I'm going to do is I'm going to plug the cylinder into that geometry input. And the next is position. And what we're going to do is get the out from get point position here that we used previously in get closest location, and we're going to plug that into position. There we are. And just as an experiment, just to see if this is working, I'm going to go ahead and instead of changing the color of the particles, I'm just going to go ahead and delete them. So I'm going to go ahead and bring in a node called delete point, and I'm going to plug result into deleted, and I'm going to plug deleted into the third port of our ice tree. I'm going to hide our cylinder, and as I scrub along there, you can see all of the particles that are inside that shape disappear. What's really interesting, of course, is that we can go ahead and animate this. So I'm going to show it again. And I'm just going to scrub ahead a little bit just so I can see the objects in my scene. I'm going to move my object a bit over to the left here. In fact, let's go over to an orthographic camera here so we can get a better view of what's going on. I'm just going to scale up my object a little bit here. And I'm going to set a keyframe there at the beginning. And I'm going to go right to the end. I'm going to send it over here and set a keyframe and maybe set a little bit of rotation on it as well. Say negative 180. Set a key there. So let's go ahead and see our object is going to be rotating in front of the object of our particle cloud rather. And let's again set our background to black so we can see better what's going on here. So there we are. And I'm going to go ahead and hide my cylinder. And we're going to go back into our main camera here so we can get an idea of what's going on. So let's start over. And you see as our object comes into the scene, it's actually actively deleting particles. So a very interesting way for us to get our particles, or rather to get volumes, get geometry interacting with the particles in the scene. But we don't want to delete particles, of course. We want to modify their color, but that gives us a basic idea that this group of nodes here, get cylinder and point and volume, work together. So basically what we're going to do is we're going to use the same technique. We're going to capture the particles that are inside the point in volume, the cylinder, by using the point in volume node, and we're going to change their color. In this case, we're going to use the multiply color by scalar node. Just going to go ahead and drag that out here. We're going to modify some of the connections here. So the first thing that we're going to do is we're going to plug the output of a get texture map into the value input of multiply color by scalar. We're also going to pull out a if node, so I'm going to go ahead and type that out, if, and drag it out into the scene. I'm going to push my ice tree node over a little bit here. So we're going to change a few connections here. I'm going to unplug this. The set particle color from the texture map, and I'm going to move it over a little bit here, right like that. And what we're going to do is we're going to basically plug the get texture map output into two different locations. We're going to have one, as we did before, going into multiply color by scalar, and the other one going into if false. And we're going to take the result of multiply color by scalar and go into if true. And we're going to export, or we're going to output rather, that result into the set particle color. Now, where does all this work in with the point in volume? Well, basically, if I plug the result into the condition here of the if statement, or the if node, what's going to happen basically is that any particles that are inside the volume are going to be essentially true, and those that are not are going to be false. And that means that basically if they're not inside the volume, they're going to use their regular texture map color, and if they are inside the volume, they're going to use whatever color is in the texture multiplied by whatever value we put into this multiply color by scalar. So I'm going to put the value to 2, which basically is going to multiply the color value, which is essentially going to make it brighter. And you see now as I drag the timeline along, I can have my object rotating across the scene here, and it's brightening all the pixels here in the Marilyn Monroe image. So let's go ahead and see how that looks in Maya. Again, just as easy as clicking on our point cloud and then clicking the Update button. We just wait a second or two for it to cache that out and then update our Maya scene for us automatically. So there we go, it's done. I'm going to Alt-Tab over to Maya, and now I'll press play, and I can see the exact same thing that we saw on the Softimage side, the Marilyn Monroe's eyes going by, along with our object with the brighter pixels. Again, we can scrub left and right to see the result. Now we could try all sorts of different things here, of course. We could try different animations with the grid. We can try different animations with our object to create a very interesting effect. So I'm just going to go ahead and make a couple of modifications to this and come to a final result, and we'll just go ahead and take a look at that in a second. So I've made a couple of modifications to the result that we had before. Just a little more animation to the grid object, and also a little more animation on our cylinder object. As well, I keyframed the factor value in the multiply color by scalar, so that on the first pass of the object it's multiplying the pixels by 2, so making them brighter, and on the second pass it's multiplying them by 0.25, thereby making them darker. So again, we're going to go ahead and select our point cloud and click on Update, and it's going to send all of that information over to Maya. And then what we can do is we can bring that object into our Maya scene and place it up in the gallery. So again, if I scrub back and forth, there I can see that all those changes have been made. So I'm just going to go ahead into the outliner here. I'm going to select my objects, edit, copy. We can of course do a whole variety of things. We can import, we can save the file out. So I'm going to open up my gallery, and this is essentially the same scene that we had before, except of course that it's empty. We're going to put our piece up on the wall, so let's go ahead and paste, and we're going to rename this group here. I'm just going to go ahead, and I had some old groups for that. I'm going to go ahead and rename this art_Softimage, and we will rotate that object. And let's kind of get a top view here, move it into place, and then a front view, and just go ahead and scale it up a little bit here. Put it next to our plaque that indicates the name of the artist. Of course, in this case, it's Softimage is the artist. And go back into perspective view. So let's go ahead and take a look at the final result in our gallery. So if I press play, there you can see exactly what we saw in Softimage is in our gallery now, up on the wall. And we have the eyes going by, and the object that's making things brighter, and then the object that's making things darker going by. Right up on the wall in our gallery next to the Softimage plaque there. So that pretty much concludes this first part of transforming through textures. That's all we're going to do in Softimage here. And now let's move on to the next segment, which is going to be working with Maya to reproduce that peg mirror. And let's move on to that. So let's dive into the Maya section now. What we're going to do is we're going to reproduce that peg mirror that we saw before. And to do that, we're going to use Python scripting in Maya. And we're also going to access Maya's API through Python using a system called OpenMaya. Now, traditionally, the API was only accessible through C++, and you had to use an IDE and code in C++ and compile a plugin. In this case, we can do all that through Python scripting without any compiling. And it's a very, very convenient way to use the power of the API without having to compile and without having to learn or know any C or C++ at all. All right, so let's flip over to Maya and get started here. So I've got a fresh Maya scene set up here, and the script editor on the right side with a Python tab open. I'm just going to go ahead and start typing out the script here, and I will describe to you exactly what's going on as I go. So the first thing that I'm going to do is I'm going to import Maya OpenMaya as OM. So this is going to allow me to access stuff in the API, as I mentioned before. I'm going to add mscript, the variable mscript, as a script utility, which is basically something that we're going to use to be able to access data in our image and do a variety of other things as well. And I'm also going to create an object of type mImage. And this is going to allow us to read an image and manipulate the pixel data inside. So I'm going to need an image path, of course. This is going to be a path to my to the image that I'm going to be using. So I already have a series of images that I've set up, amongst others, of course, the image of Elvis that you saw before. So we'll just type out elvis.bmp. So the first thing that I'm going to do is read from file image path. So I'm going to read the data inside that file. And there's also a way to be able to automatically figure out, with the mscript util, figure out the height and the width of the image. It takes about 12 lines from the way that I know how to do it. There might be a more efficient way, but just for the purposes of keeping this example simple, I'm going to go ahead and manually set the height and the width here. So if you start doing this with a different sized image, it's very important for you to modify those two values. So I know that my picture of Elvis in my case here in Photoshop is 32 by 32. So I'm also going to have another variable here that's going to be the size. So I'll do width times height. So that's going to allow me to know how many pixels I have in my image, which in this case I know is 1024 pixels. So there, I'm now going to type out pixel pointer, and basically all that this is just a place in memory where the information for those pixels reside. So the colors of each of those pixels is going to sit in memory somewhere, and this is going to give me the address of where that is in memory. So I'm going to use image.pixels to read that into my pixel pointer. And then I'm basically just going to go through one pixel at a time. I'm going to start from number 0 and make my way up to number 1023, since we're starting at 0. So we'll say while pixel number is smaller than size, so while I'm not yet through all 1024 of my pixels, first thing I'm going to do is I'm going to get my pixel index, which is going to be pixel number times 4. Now what does this mean? Basically, the information that I'm going to be extracting from pixel pointer is going to be giving it to me in sets of 4: red, green, blue, and alpha. So I'm going to be basically going through sets of 4 numbers, and I'm just going to be looking at the first 3, which is going to be the red, green, and blue values. How do we do that? In this case, we're going to say red equals, and we're going to use our mscript utility. We're going to use a command called get uchar array item, and that's basically going to get an item inside an array, then this list of pixel colors. And I'm going to look in the pixel pointer at the pixel index. In this case, it's going to be the first one, the red. So I'm just going to go ahead and copy that line, and we'll go to the end and we'll paste it 2 more times. And I'm just going to set this to green, this to blue, and since we're starting at red and then the next one is green, we're going to go +1, and the next one is blue, we're going to go +2. Next thing we're going to do is we're going to print out those values just so we can take a look at them. So I'm going to first print out the pixel number so that we know which one we're at. Then we'll see the red, the green, and the blue. When we're done, of course, it's important for us to move ahead by 1, so I'm just going to go pixel number plus equals 1, and that should be pretty good. So we're just going to select everything here and press enter. So there we go. So you see it's running through each of the pixels, and it's printing out the red, the green, and the blue values. So it should end at 1023. Yes, it does. So I'm going to zoom in a little bit here just so that you can see, get a bit of a better look. So each of these, of course, represents a red, a green, and a blue value. So we know that this works, but now, of course, we want to do something interesting with it instead of just printing out a bunch of numbers in the display. So before we do that, though, we're going to need objects to affect in our Maya scene. So I'm going to open up a new Python tab over here. And I'm just going to write a quick little Python script to be able to generate a series of objects in our scene. So I'm going to type import maya.cmds, as CMDS, or commands. Basically, this is going to allow me to just access the regular Maya commands and not the stuff that's in Open Maya. And I'm going to write for I in range 32. And I'm going to be, oops, I missed my 2 dots there. And then for j in range, I'm going to be basically doing a loop within a loop. So I'm going to be doing the horizontal axis of pixels, 32, and then another 32 in the vertical axis. And I'm just going to create a series of objects. Let's say obj equals commands dot. In this case, we'll just do cylinders. So polycylinder, our radius, let's make it 0.5. And we're going to give it a name so that we have sort of a reference. For those of you who don't know, if you put the number sign in an object name when you create it, it essentially is going to increment it by 1 each time. So it's going to start with 1 and then go 2, 3, 4, 5, etc., etc. And then I'm also going to move them. So I'll do commands.xform. It's going to be my object in this case that I just created. World space is true. Of course, I want to move it in world space. And then my translate is going to be negative I, 0, and negative j. So I'm basically going to be going through 0, 1, 2, 3 up to 32, 0, 1, 2, 3 up to 32 again. And I'll be placing it at 0, 0, 0, 1, 0, 2, 0, 3, and then 1, 0, 1, 1, 1, 2, 1, 3, so on and so forth to create a grid of objects. So I'll just go ahead and close those parentheses and run this. And you can see now that it's created a whole series of cylinders. So I'll go ahead and hide the grid. So I've got a bunch of cylinders in my scene here. And you can create any sort of objects that you want, of course. So what we want to do now that we have a series of objects to manipulate is that we want to go ahead and transfer the information that we have from our image onto those cylinders. So we're going to make a couple of modifications to our script, not too many though. We're going to come back at the top here and we're going to import Maya CMDS as CMDS, so we're going to add our commands. And we're going to basically add a couple of things here. Now, you noticed probably before that the values that were printed out came out in between 0 and 255. And for what we want to do in this case is we want to actually get values that are between 0 and 1. So I'm just going to type red equals red divided by 255.0 because we want it to be a floating point number. And let's copy that out a few more times. Green, and do the same thing for green, and of course do the same thing for blue. There we go. Now, instead of printing, of course, we want to do something else. First thing that we're going to do is we're going to say get our object. So it's going to be object equals object plus. We're going to be adding to our string, so we'll cast to str, in this case string, and pixel number plus 1. Now, because we're going to be starting at, we called our first object, in this case object 1. If I go ahead and select it, I think it's probably this one down here. Here we go. The first cylinder down here is object 1. So we want to go from object 1, 2, 3, 4, etc., all the way up to object 1024. So we're going to be starting at pixel number 0 because that's how the pixel pointer is going to be giving us our data. But we are starting at object 1. So we're just going to take the pixel number and add 1, and that's how we're going to have that relationship between our pixels in our image and the cylinders that we have in our grid here. So we're going to say our object, the object we're going to work on at each iteration through the loop is going to be our pixel number plus 1. And then we're going to do a couple of commands here. We're going to do poly options, object, and color shaded display equals true. Basically, this is just going to turn a vertex color on for that object. And then we'll do poly color per vertex, which is going to add vertex color onto our object. We'll do object and RGB equals red, green, blue. So close parentheses, and then we're going to increment our pixel by 1. And I'm also just going to go ahead and add a commands refresh, and that's basically going to refresh the viewport each time we make a change. So let's just summarize exactly what we've done here. We have taken our red, green, and blue values and converted them from being between 0 and 255 to being between 0 and 1. So again, in the case of 128, will become 0.5. We've got the name of our object, so we'll go through our objects one at a time. We are going to activate color shaded display on our object, and then we're going to go ahead and apply vertex color onto that object based upon the red, green, and blue value in that pixel. So in this case, it's going to be our image of Elvis. Let's go ahead and apply that, and you can see that we have each cylinder colored the same color as the pixel in our image. Kind of cool there. And it sort of reminds us, of course, of the Christian 4 crayon images as well. If we get up close here, could be kind of interesting as a render with some depth of field there. So now let's move on to the next step of creating that peg mirror in Maya. We know how to read our red, green, and blue values of a pixel by reading it in through an image, through mimage. But now what we want to do is create a series of pegs and rotate them based upon the intensity or the brightness of those pixels in that image. And in this case, of course, we're also going to be using black and white images. And I'll just show you a quick example. Here's one of George Washington, Che Guevara, and Einstein. So basically, I'm just going to go ahead in Maya and open up our peg object to give you an idea of what I'm talking about here and how this is going to work. So we have our peg object, and I'm going to go ahead and create a directional light. I'm just going to move that over. And I'm going to rotate it about 45 degrees downwards. And it's also facing essentially in the negative Z direction. If I press 7 on the keyboard, it brings me into lighting mode, and I'm going to go ahead and rotate this cylinder to show you that as I rotate it towards the light, it gets brighter. They're darker and brighter. So 0 degrees and 180 degrees. So what we're going to do is we're going to go through our images, and every time we find a pixel that's black, we're not going to rotate our cylinder. Every time we find a pixel that's white, we're going to rotate it 180 degrees. And every time we find something gray, we're going to go a little bit in between, about 90 degrees. So the first thing that we need to do in this case is to set up a whole series of these cylinders. So I'm just going to move this light out of the way. I'm going to go ahead and grab the peg object here. I'm going to go into Edit, and I'm going to open up Duplicate Special and reset all of our settings. So the first thing we need to do is to set everything in the x-axis. So I'm just going to duplicate this 1 unit each time and duplicate it 31 times. Of course, not 32, because this is our 30-second object here. I go ahead and click Apply. And I'll select all those objects again, put 0 in the Translate, and I'm going to put -1 in the Z, and duplicate that. So now we've got a whole series of cylinders, as you can see. And if I press 7 to go into lighted mode, and I select just a few of them at random here, and rotate them, you will see that as they start facing towards the light, they get brighter. And if I look at it from a top view, you sort of get the impression that some of these things are lit up, or that the pixels are brighter. So let's undo and set it back to default. Move our light over here. Now we're going to make a couple of modifications to our script so that instead of setting the vertex color on these pegs, we're actually going to be rotating them in the y-axis. So the first thing that we're going to do is we're going to modify our image, of course. The image of Elvis is going to be no longer applicable in this case because we want something that's going to have grayscale values. So I'm just going to type in Washington. So we're going to take that image of George Washington. And if we scroll down here, we're actually going to take a bunch of stuff out of our script. It's actually going to be even simpler. If I flip over to Photoshop here and I move over to my picture of George Washington and open up the Info tab over here, you can see as I move my mouse over the image and you look at the RGB section here, you can see that all of the values are always the same. Because it's a grayscale image. So the number that we have in red is going to be the same as green and in blue. So in my script, I'm only really going to need red to do this, and I'm going to just replace the word red with value just because it's going to keep things a little simpler. I'm going to replace the word red with value here as well, because we want to deal with a number that's between 0 and 255 again. But we're going to do one little modification here, where we're going to say that value is also equal to that times 180. So basically, first we make it between 0 and 1. And then if we get 0, in other words, a black pixel, we don't want to rotate we want to rotate 0 degrees, essentially. And if we get a white pixel, in other words, 1, we want to rotate 180 degrees. And then the last thing we're going to do here, we're going to use the xform command. And we're going to rotate our object, RO equals, and we're going to do 0 degrees in the x, value, in other words, the rotation value we calculated in the y, and then 0 in the z. So that's the basic idea. We're going to get the brightness of the pixel, we're going to make it between 0 and 180, and then we're going to use xform to rotate it. Now if we go ahead and run this script, you can see it's going to rotate all the cylinders in such a way to reflect the brightness of each one of those pixels. So you see if I go into a free cam mode, you can get an idea of how they were all rotated. It's a little hard to see the contrast here, so what I'm going to go ahead and do is select my directional light, and I'm just going to bump up the intensity a little bit here. There we go. So that gives us a much better idea of what's going on with our image. Now what's really fun is that we can go ahead and start modifying these images for others. So I can say Guevara and run that. It's going to flip everything. Again, if I go into our free camera mode, you can see how it's rotated all the cylinders in consequence. And finally, Einstein. There we go. I'm going to probably bring down the intensity a little bit there so that we can see a little more contrast. There we go, it was a little bit too much before. And let's go back to our Washington. There we go. So now what's really interesting about this is that we can start animating and transitioning between different states. So what I'm going to do is I'm going to set this to 500 so that it's going to be synchronized with the Softimage image that we created before. And I'm just going to select all of these cylinders. I'm going to press S to keyframe them. I'm going to go all the way to the last frame and press S again to keyframe so that we can basically have a loop. And I'm going to go ahead and start animating or transitioning from one state to another. So I'm going to press S here. I'm going to move, let's say about maybe a couple of frames ahead here. And I'm going to change the image to, say, Che Guevara. And I'm going to select everything and keyframe that. And move that over here. Set another keyframe and move forward a little bit and modify that to be Einstein. Select everything, keyframe, and set another key here. Set everything to Einstein and keyframe that as well. So let's just to back up a little bit here and see. We transition over to Che Guevara, and then to Einstein, and then back to George Washington. So we could set that onto a loop. So let's just go ahead and move some of those keyframes back so they're a little more evenly distributed. There we go. So what's really interesting as well is when you look at it from this perspective. So if I go ahead and press play, it's very interesting to see all of these pegs moving as they're transitioning from one image to the next. So let's go ahead and check it out again in our top view as it goes back into Washington there at the end. So we've got a nice little loop going. So that's really really interesting, and it's almost ready to be put into our gallery. But there's just one last thing that I would like to be able to do, and that is to transition, control the transition based upon an image as well. So right now, all of the pegs are turning at the same time. As you can see, if I select my pegs here, I have my keyframes, and they're all turning at the same time. But it would be very interesting to be able to offset those keyframes based upon another image. So what I'm going to do just to start off is I'm going to move all of these even further back here so that if I start to offset them, they're not going to go outside of the bounds of the image. So, okay. So what we're going to do is we're going to open up another image that I have here, which is an offset. So basically, what I'd like to be able to do is to have the pixels that are in the cylinders, pegs rather, that are in the dark pixels to transition first, and then have the ones that are white to transition last. So what we're basically going to do is we're going to scale those keyframes based upon this image, and then we can modify this image to make the transitions go differently. So not a lot of modification required. First thing that we're going to do is we're going to set this to offset. Next thing we're going to do is we're going to scroll down here, and we see that we have everything here again in value equals value divided by 255. We're not going to be rotating, we're just going to be pushing the keys forward. So we're just going to remove this line here that multiplies the value by 180 because we're not rotating. And we're going to add a new variable here called time change. And I'm just going to take value times 100. So whatever number comes out of here times 100, we're going to be able to use that that number here to have some interesting, some different effects. So then finally, I'm going to replace this command, the xform command, with the keyframe command. So I'm going to be doing this on an object. I want it to be editable true or edit true. And let's just go ahead and just fill in the rest of this here. Time is going to be equal to 0 to, let's say, 500 in our case. And that's true. And then time change. So TC is time change. That is going to be this variable here. And that determines how far along we're going to push each of those the keyframes of each of those pegs. So that's about it basically. So again, what we're going to do if I select one of my pegs is if we find a dark pixel here, we're not going to push the keyframes over at all. We find a light pixel, we're going to move it over a lot. So let's go ahead and run that. Now you see if I select all the pegs, you can see that the keyframes have been spread all over the place. If I go ahead and run it, you can see that the transitions are happening from the inside out rather. A nice smooth transition as it moves on to the next one. And then finally from Einstein back to Washington, and a nice little loop. But what's really great about this is that we can go ahead and stack these. I have another image here which is a noise, so it's just a bunch of random pixels. So I can go back in here and set this to noise, and I'm going to set this to maybe a lower value, maybe just 25. So it's not going to push the keyframes around too much. I'm going to go ahead and run that, so it's going to displace the keyframes a little bit more again. So we'll go ahead and run that, and we'll see that we will still have that same effect coming from the inside out, but we have kind of a pixely, shimmery effect that happens. So you can see here again, you get that same effect. Very, very interesting. So you can continue to layer these different effects, and you can, of course, go ahead and modify your images if you want to. So I'm going to go ahead and select my my keyframes, and I'm just going to undo to the point where I go back to before we started making these modifications. Okay, and you'll see that in Photoshop, for example, here I can go ahead and select the gradient tool, and I can add any sort of modification onto this gradient that I want. I'm going to go ahead and save, and set this back to offset, and run that. And you'll see now, again, because I modified that image, the transition is going to happen with a stripe effect. So you can see the horizontal stripes going across as it transitions from one to the next. So now here we can see our final scene with everything combined together. the Softimage piece on the left and the Maya piece on the right. So that concludes Transforming Through Textures. Thank you very much for taking the time to listen to this masterclass. I really hope that you enjoyed it and that you learned a lot from it. I'd be very, very happy to hear your questions, and if you would like, you can also visit my website at www.davidlightbown.com, or you can email me at info@davidlightbown.com. Thank you very much.